Okay, so we've now discussed what happens to the electrical potential difference across the cell membrane when you open these 5-HT3 receptors. Now, that's great. That's going to excite neurons. It's because when neurons become depolarized, that's going to raise the chance that that neuron will then fire. Okay, now let's continue our discussion of what happens to the receptor, however. The question is, once serotonin has bound to the extracellular domain of this 5-HT3 receptor, does the receptor remain open just permanently after that? And the answer, of course, is no. So basically, it goes into the open state for a while, and then it goes into another closed state. So basically, it starts in a closed state known as the closed resting state, and then when ligand binds, it goes temporarily into an open state, and then after a little bit of time, it goes back into another closed state. But this is a different closed state to the closed resting state, because in this closed state, you still have ligand bound to you. So here is the ligand still bound. So this is what's known as the closed /desensitized state, because it's desensitized to the fact that the ligand is still bound to it. It's ignoring the ligand in effect. Right. Okay, so the question is, how long does it remain open for when the ligand initially binds? Well, the answer is, it's not a set number. Instead, it's a probabilistic process. Some of them will remain open, you'll get a few freaks which close very, very quickly, and some of them will remain open for a very, very long time, and it will vary between receptors, and it will vary between different times. So the same receptor, if you activate it at different times, will just take longer to close sometimes, and it's just a probabilistic process. However, even with probabilistic processes, we can still formulate an average time that it takes to go from the open to the closed desensitized state, and this is what's known as the mean open time. So the mean open time, which is the average time for which the receptor is open before it goes into the closed desensitized state. Right, okay, so to review the entire process, you start off with this closed resting state, and then when the ligand binds, it goes temporarily into the open state. It remains open for a little while, allowing a net movement of positive charge into the cell, which results in the depolarization of the electrical potential difference across the cell membrane. And then, after a certain amount of time, of which there is an average known as the mean open time, it will go from the open state into what's known as the closed desensitized state, where it still has ligand bound, but it is no longer open. And this prevents these receptors from hyper-exciting the cell. Right. Okay, so there we have revised the structure and function of the 5-HT3 receptors. Let's now talk about their role in depression. Now, it's fair to say that this doesn't really fit with other things that we know about depression. So basically, the modern view of depression, well, at least the pharmacologist's view of depression, the psychologists might disagree, but the pharmacologist's view of depression is that what happens is that the levels of noradrenaline and serotonin within the brain are too low. So noradrenaline is too low, and serotonin is too low. Okay, serotonin is the same as 5-HT. So these two neurotransmitters are too low, and that's what causes depression, is what the sort of central dogma in, as far as pharmacologists are concerned, with depression. Okay, so the most famous drug of all the antidepressants is the drug which is known by the infamous brand name Prozac. Okay, and the proper name for Prozac is fluoxetine. Fluoxetine. Okay, so what does fluoxetine do? Well, it's what is known as an SSRI. So it's an SSRI. And SSRI stands for serotonin selective reuptake inhibitor. serotonin, or it might be selective serotonin reuptake inhibitor. I think I prefer selective serotonin reuptake inhibitor. Don't think it matters. I think both terms are used to count this first S as serotonin and then the second one as selective, and then the first one as selective and the second as serotonin. I think both are used. I think I prefer, however, selective serotonin reuptake inhibitor. Okay, so basically, when neurons in the brain release serotonin, okay, and there's not a huge number of neurons in the brain that release serotonin. When you think of the number of neurons in the brain, there aren't that many at all which release serotonin. Okay, and they're mainly based in the raphe nucleus, and they have their projections going all over the brain. So let's draw the axon terminal here of a serotonergic neuron. Okay, so here is our serotonergic neuron. So basically, it's releasing 5-HT. So here comes out serotonin, or 5-HT. And then it terminates the signal. So it basically has a transporter on its membrane here. So I'll colour this transporter in, this blue colour here. Okay, so this transporter in blue, this is what's known as the SERT. Okay, and SERT stands for Serotonin Reuptake Transporter. So this is the serotonin, so the SE is the serotonin, so SE serotonin, and then the R is for reuptake, and then finally the T is for transporter. So this basically, its role is to pump serotonin from the extracellular fluid back into the axon terminal. Okay, so the thought is, if we inhibit this SERT, if we inhibit the serotonin reuptake transporter, then we'll stop the reuptake of serotonin from the extracellular fluid, and therefore the level of serotonin within the extracellular fluid will go up. So serotonergic neurotransmission will go up. Okay, and yes, okay, this isn't going to have any effect on noradrenaline, but it's thought generally that serotonin being too low is the one which actually makes you have low mood. Noradrenaline being too low is what leads to you feeling tired all the time. So this produces tiredness. Okay, and serotonin being too low is what produces a low mood. So this produces low energy. This produces the low mood. Okay, so many antidepressants just target the serotonin system rather than the noradrenaline system. Okay, so fluoxetine basically is a drug which blocks this serotonin reuptake transporter, so it inhibits the actions of this transporter and therefore raises the levels of 5-HT within the brain. Okay, so more 5-HT, and that seems to up your mood. Now, this is the odd thing, basically, with 5-HT3 receptors, because the dogma here is more serotonin, happier, okay? Whereas, more 5-HT3 activity, so if the 5-HT3 receptors are too active, that actually leads to depression. So basically, it seems to go against this sort of theory here. But you have to remember that these 5-HT3 receptors, they just represent one type of serotonin receptor. There are the other whole 6 families of serotonin receptor which are potentially more important in controlling your mood than the 5-HT3 receptor. However, we will see the involvement of the 5-HT3 receptor just now. So, when you up serotonin by blocking the serotonin reuptake transporter, this will be acting basically on the other types of 5-HT3 receptors to make you happy, basically. So this does seem to increase happiness. Okay, but with regards to the 5-HT3 receptor, if you have too much activity of the 5-HT3 receptor, so if the activity of the 5-HT3 receptors goes up, i.e. it's too active, this produces depression. Okay, so why is the question? Well, what we think is it it may be acting presynaptically, so you may have 5-HT3 receptors which are involved in stopping the release of more 5-HT. So potentially these are involved in the presynaptic inhibition of the neurons which release the serotonin. So let me go over this again. Basically, when you have this serotonergic neuron here that's releasing serotonin, it will have receptors presynaptically which will be activated by the serotonin. So I'll draw one of these. So I'll just put a blob here. Okay, and these will the serotonin that they've released will activate these presynaptic receptors here, and the presynaptic receptor will then stop the release of further serotonin. So the idea is that once you've got enough serotonin being released, you don't want to release any more, so the presynaptic receptor will inhibit the release of further serotonin, basically. Okay, so these 5-HT3 receptors may well be involved in the presynaptic inhibition, and that would make sense, basically, because if you had too much activity in these presynaptic inhibitory receptors, then that would stop the release of 5-HT from these synaptic terminals, and therefore you'd end up with too low 5-HT levels. Okay, so we'll continue this discussion in the next video.